How's it going, everybody? In this video, I'm going to go ahead and give everybody kind of a high-level overview as to how I go about speccing out hardware for my labs, specifically the servers, because I get a lot of questions on that. And I really wanted to try to provide some concise, specifics, on-target answers for you guys to help you understand, how I go about choosing a particular server. What CPU am I looking at? How much RAM am I looking at? What is the storage going to come into play? Licensing, why I choose ESXi versus Hyper-V, or doing some sort of a bare metal install with Eve and stuff like that. So let's get started. So what we're going to take a look at in this video is specifically the servers. So I'm not really going to focus on anything else. I'll talk about labs and how I go about that in a different video. But I'm actually going to show you my oldest server first, just so you have an idea of what's going on and stuff like that. Now, I originally was looking up servers. This is probably going back now 7-8 years ago. And one of the first things that I did, and I didn't really know how to buy a server. I'll be completely honest with you. There was some trial and error stuff. And I realized that I really didn't know what I was looking at. And it was only because of the fact that I had somewhat of a basic systems engineering foundation that it really helped me understand what I needed to have and stuff like that in order to make whatever I was doing successful. So why does that matter? Well, it matters because if you are trying to build a home lab, I chose to go home lab versus trying to do like rack rentals or upload something to the cloud, like in an Amazon or Azure or something like that. Only because of the fact that it was, at the time I was using INE a lot for I still am, for security and routing and switching, service provider, data center training, and I needed something to lab all the stuff up with. Initially, in the very beginning, it was obviously Packet Tracer, but for those of you that have been dealing with Cisco for any length of time, the Packet Tracer sucks, and it's once you get above a CCNA level, Packet Tracer really doesn't have any value. So I hadn't even completed my CCNA, and realizing the limitations, I decided to flip over to, because I needed to. I needed more capabilities than what Packet Tracer had. And at that point in time, I was like, well, Packet Tracer stinks because now I can't go lab up these technologies because the Packet Tracer just doesn't support those capabilities. And it still doesn't. There's a lot of things that Packet Tracer doesn't do. So another engineer introduced me to GNS3, and then I switched gears and went over to GNS3. One of the best decisions I ever made initially. I got GNS3 up and running, and then after a period of time, I realized that there were limitations to GNS3. Like at the time, I was studying for a CCNP switch, and you can't emulate. At least back 6-7 years ago, you couldn't emulate switching in GNS3. So I had physical switches. I still have those switches. They're actually down in my basement, powered off because they're older. 3550s, 2950s. You spend $30-40 on eBay, you get some hardware. But the cool thing about it is it gave me gave me the ability to play around with the technology. And that was really important to me. So with that being said, I took advantage of those capabilities. But fast forward another year or so, I've completed my CCNP at this point, and now I'm working on the CCIE. And about that same point in time is when CCIE version 4 flipped over to CCIE version 5. And this is 2013, 2014? Yeah, about that. So by converting over, I needed something that was beefier. Like my local computer just couldn't support the amount of routers and switches that I needed. So I remember watching a INE video on an introduction to DMVPN with Brian McGann, and I was like, I didn't know what platform he was on, how to get any of that stuff working. So I just started asking questions, just like you guys asked me. And I realized, he was just like, well, this is a server running on we're running ESXi, and I run these virtual routers as virtual machines. And then he talked about how you connect the routers to a vSwitch, and I was just like, so now that I have at least some understanding, I just started Googling stuff, looking this up, looking that up, and I actually recorded a video on it a long time ago. It's actually a rather popular video on my channel. It's just older; most people don't see it. So I went through and did that. I went out, I bought a server. Now, what server did I buy? At the time, it was a Dell C1100, which is the same form factor as Cisco UCS C220. But the Dell had problems. It was refurbished. It was, there were obviously most of the hardware I've gotten is secondhand. So I buy what would have been a $10,000 server current day. When I buy it, it's $200, $300, $400, and then I just buy whatever I need to in order to build it out. So currently, I have 3 servers in my basement. I have the 3 servers that I have are the vSphere client connections that I have to my 3 servers, and my first one, it was 32 or 24 gigs of RAM, and I don't remember the CPU because it's been so long. It doesn't really matter. The current CPU, the current servers that I'm working on, so the one right here, this is the second oldest one. So I bought this one, but at the time I was working for a company that did a lot of virtualization. It was a managed service provider, and we had a lot of VMware deployed. So I was working with VMware a lot. And so when I say working with it, that means I'm logging into vCenter and I'm interacting with virtual machines. When people call up and they have a problem, jumping on a remote desktop connection to a VM, that was what I was doing. I was just rebooting VMs. Don't get me wrong and think I was doing something cool, because I wasn't. I was doing what I needed to do in order to do my job. So I learned a lot of that. And what ended up happening was one of the systems engineers that worked at the company that I was working at, he was passing through, and I intentionally kept an eye out for him. And when he passed through, I popped up, and I don't even remember the guy's name, to be honest with you. Nice dude, though. I said, hey, I have a question for you. I said, do you have a couple minutes? And I was actually just starting my lunch break, and he's just like, well, I'm kind of busy at the moment. Can I come back in like 20 minutes? I said, yeah, sure, no problem. And then he popped back and he goes, what's up? And I said, I need your help with CPUs. I don't understand CPUs and servers. And he goes, what are you trying to do? And I said, well, I'm trying to build a VMware server. I want to install ESXi on a server so that I can run virtual routers inside of my server. And he's just like, oh, okay, sure, no problem. And he goes, do you have a couple minutes? I said, yeah. So he walked me to his desk, and he pulled up vCenter at the time. I think it was 4 dot something, because it's a long time ago. And he showed me, he's just like, you see this stuff right here? He actually, because it was a different UI, but since I don't have vCenter, I'm showing you the very similar output. Right here, the Intel Xeon CPU X5560 2.8 gigahertz. This is licensed, so I finally got myself a license, finally. Instead of having to rebuild the servers every so often. This has got 2 physical cores, and each core has 4 sockets. So 2 physical sockets, each socket has 4 cores, and that would give me 8 total cores, and then you hyperthread that, then it gives you 16 logical processors. So in theory, I should be able to run 16 VMs, 1 CPU per VM, but I'm obviously not doing that because a lot of these servers that I'm running have multiple vCPUs. So I'm actually getting rather good performance out of them because I'm not overextending the servers. I've actually cleaned it up quite a bit because it was starting to get really sluggish. But so let me talk to you a little bit about how this comes into play. Let me go ahead and pull up Firefox and talk a little bit about how I made the determination to do what I did. So take this into consideration. So let me go ahead and jump out of the way. And in here, we're just going to go to Google. Google.com. So if we were to look up the server, right? So we have this CPU right here, type in Intel X5560, right? I come in here and I don't waste any time going down to here, right? I go right to Intel's architecture website. I click on it and then I look here. So what I go do is I come down here to where it says Advanced Technologies. Advanced Technologies is going to tell me all the information that I care about, right? This is the virtualization specifications, things like that. So what we're looking for is down here. We're looking for hyperthreading technology is supported. And if you don't know what any of that stuff is, you can click on this and it'll give you some information. It'll tell you that delivers 2 processing threads per physical core. Highly threaded applications can get more work done in parallel, completing tasks sooner. So it allows you to use both CPUs at the same time instead of doing a single core or non-hyper-threaded where you're doing one thread at a time instead of using multiple cores. So this one also has Intel VTX. This one says allows one hardware platform to function as multiple virtual platforms. It offers improved manageability by limiting downtime and maintaining productivity by isolating computing activities into separate partitions. Again, this is really important because this gives you that flexibility of running nested virtualization. This basically allows a VM like Eve or the FMC, Eve more specifically, that's going to have VMs running inside of it, or nested virtualization, to basically think of it like the VM punching a hole in itself and allowing the VMs that's running inside of it. So like a couple of routers or a firewall or a couple switches to be able to look through the Eve platform and see through it down to the CPU itself and go, oh, well, I know what particular platform it is because that's what's up, because that allows you to pass that information through. So these are just some of the things you'll come into play. And if you don't know what the extended pages table, this is second level address translation or SLAT. Provides acceleration for memory-intensive virtualized applications. Reduces the memory and power overhead costs and increases battery life, but we don't really have to worry about that. So basically that's where the ability to carve up the memory and the CPU between the virtualization technology and the extended page tables basically allows you to carve up the physical RAM and CPU of the server and divvy it up and provide a resource reservation if you need to. VMware does support that. If you need to do that on a per VM basis. I don't do that in my lab because I really don't care, but it is an option. So that's this CPU. Now if I come down here to my older one, this is a CPU that's an E7330. So if I come back over here and I pull this guy in here, I type in E7330 and I come to the ARC website, right? And I come down here to Advanced Technologies, you'll notice that hyperthreading is not supported, right? VTX is. So I can virtualize and I can boot a VM. But if I wanted to do anything advanced, I wouldn't be able to. So I wouldn't be hyperthreading, and it says it right here that hyperthreading is inactive because it's not supported. So I have 4, so in this case here, I've got 2 processor sockets. This server's got 4 physical CPUs, and I've got 4 cores per socket, which means it gives me a total of 16. So there's no 16 is the most I can run here. But this server is a workhorse. I obviously have much more running. These PCs right here are not running very hard at all, but this server is used for some other testing and stuff like that I'm doing. There used to be a lot more running on it, but I can run a lot on here and it works really well. It's just that the experience is rather slow. So I don't recommend getting this particular model CPU because it doesn't support the hyperthreading. It has to do with the architecture of the platform. You will be able to boot a VM to it, right? That will be supported here. So you can do you can run virtual platforms. So I can boot virtual machines inside of that particular ESXi server. However, other advanced capabilities aren't there. So let's go look at the last one. This is going to be this is my UCS server, and this guy right here is an E5 2620, 2.2 gigahertz. So if we come back over here, and it's an Intel E5. Sorry about that. I forgot that if I put a dash in here, it pauses. So this server's got all the capabilities, all the bells and whistles that I needed to have, and it's got a lot going on, right? There's several things that come into play with this. That it is a workhorse, right? So I have 2 physical CPUs in it, and then I have 6 cores per socket. So that's 12 total 12 total logical processors. With hyperthreading, it doubles that to 24. So just so you understand how this works, if hyperthreading is enabled, so if you have one CPU that's got 16 logical cores, so it's one socket, 16 cores, right? That's where the cores per socket comes into play. So if you have one physical CPU and that CPU has 16 cores, you add a second CPU with 16 cores, that means you have a total of 32 cores. You add hyperthreading to that, that means you have 64 cores. So hyperthreading allows you to basically share and load balance and double your capacity. So it's very, very cool how that comes into play. I'll talk about that more in detail. There's another server that I have on order for some work-related stuff that we're going to be putting in here that I will be showing you how some of that type of stuff works. It's a much newer server. Lots of resources on it. So that's basically how I went about doing that. So let's shift the gear from CPU. So now you know the CPU. You want to look for CPUs that have hyperthreading enabled and that have virtualization technology capabilities. Hyperthreading is a big deal. So in other words, with the hyperthreading specifically, there's that, like if I needed to run Eve on this server and then I wanted to spin up a VM inside of it, so like launch a new router, then that wouldn't be supported here because the ability of passing the nested VM, so a router running inside of Eve, down to the CPU here is not supported. I did look it up a long time ago. There is a legit issue with it. So I'm like, okay, well, I just can't run that there. So it sucks, but it is what it is. But I can run things on here that are just going to be a regular VM. Like I can load up CSR 1000Vs here, XRV. I can load up Firepower, ASAs, Nexus 9Ks, Windows PCs, Linux PCs. I can virtualize anything at the hypervisor level, but if I want to do any type of nested virtualization like Eve or Viral or anything like that, where I install an Eve VM and then I run routers or switches, firewalls or whatever inside of that, that won't work on this particular server. So let's talk a little bit about the RAM. So initially my servers came with 64 gigs of RAM, and through a combination of working with clients and they're decommissioning hardware, and I need to go through and I'm like, hey, since you're throwing this out anyway, do you mind if I cobble together, do you mind if I cannibalize the server? A lot of times my customers have been like, do you just want the server? I'm like, sure, I'll take it home. And I load it up in my car and I bring it home and I take whatever I need out of it. I've got 3 or 4 servers in my basement that are just from customers that they got rid of it. They already took the hard drives out of it. They're like, there's no hard drives in it. I'm like, okay, I'll go buy a hard drive. Man, what's that, $50? I can afford that. So that's what I would do. And the other half of it has been going out and buying a memory pack where you go online, you find out how much RAM is. I would literally pull out RAM and be like, okay, I'd pull all the specifics off the RAM stick. I'd go look it up and find out, okay, how much of, let's say they're 8 gig sticks, and I want to go from 64 to 128. That means I need to go from 8 to 16. So I would order 8 more sticks, assuming that I have slots for it. One of the major issues that I ran into was figuring out the RAM slotting that I needed to know in order to get all of the RAM to be detected. Because if you just put it in any random bank and order, it'll mess things up, and sometimes it won't boot, sometimes it won't recognize it. So there's a lot of trial and error, and I haven't really found any really good documentation on IBM servers or really Cisco servers either to figure out how do I take advantage of the RAM and things like that. So a lot of trial and error on that, but I finally was able to get all of my servers to recognize 128 gigs of RAM. I had to go out and spend some money. Sometimes it was $250, the price of a firewall I spent on RAM. But it's actually kind of funny. Since I started running Eve about 1.5 years ago, it really isn't a RAM issue anymore. It's CPU. Like for example here, I'm running a couple of Eve server. I'm running 2 Eve servers here, and obviously Call Manager Express, and I've got Unity and some other stuff, and IAM and Presence. They're not powered on at the moment, but when they are, the CPU climbs. And I'm doing some security-based studies as well, so I'm having to deal with that. But the running ICE, so I take a lot of those aspects, and it climbs the RAM or it climbs the CPU. So just keep that in mind as you're moving forward with your testing and things like that. For storage, I'm very, very straightforward. I went out and I bought a QNAP storage appliance, really good stuff. It's a unit about the size of a couple cereal boxes. It's about 6 inches wide, about 8 inches tall, about a foot deep. It's got 3 4 terabyte hard drives in it, and it's cool because I can pick and choose how the hard drives are carved up. So I've got one 4 terabyte drive that's dedicated to nothing but SAN. So I've got an iSCSI target set up on it, and that's where this comes into play. So there's 2 physical gigabit connections. So one goes into a SAN switch, if you will. It's just iSCSI. It's a little gigabit 8-port Netgear switch that's providing the connectivity between the QNAP and then the 3 servers. And then I have the onboard data store. This is where I install ESXi. So it's just a regular non-SSD hard drive. It's either like a 7200 RPM or 10,000 RPM SAS drive. Usually I just go online. I buy a 146 gig or like a 72 gig or whatever size hard drive it is. That's 10,000 or 15,000 RPM, and just do that, and it works just fine. So I don't run SSDs. I don't need anything high performing because it's a home lab. But having the storage built out like that means I can build out a SAN. I understand how iSCSI works. That was kind of a big deal to know how to do that. But that's basically my home lab. That's how the physical servers are built and things like that. If you have any questions, leave a comment in the comment section below, and I will do my best to try to answer any of those questions and stuff like that. And until next time, guys, take it easy.